Today we'll learn how to port our game over to mobile phones by making it accept touch input swipe gestures to control the player's left and right turns in the game, as well as his jump and slide animations. So let's begin. But first we need to understand what's happening under the hood when the user swipes one of his fingers across the phone screen, so that we know how to program this behavior in Unity. To that end, I've created this interactive diagram that should help us in understanding the life cycle of a gesture swipe in geometric terms. Here, we have a typical modern smartphone in landscape mode, and I have imposed a hypothetical rectangular coordinate system with its origin being on the center of the screen to track the user finger movement on the screen. This screen is 1080 pixels high and 1920 pixels wide, so it's a typical Full HD screen. Now suppose the user places one of his fingers on the center of the screen, given by the coordinate pairs x1, y1, and then drags it across like so, until he reaches the position on the screen given by the coordinates x2, y2. After that, he lifts his finger off the screen. Let's consider this to be a swipe that we can detect, and we know exactly where this swipe has started and where it has ended on the phone screen, which is at x1, y1, and x2, y2 respectively. Let's also consider the distance between x1 and y1 and x2, y2, which is the swipe distance, to be 100 pixels. Then, by basic properties of rectangular coordinates, this line created by the swipe distance always makes a right angle with the x-axis. Let's call this angle theta. Now let's think about something. Wouldn't you agree that if we know the value of this angle, then we can tell how the user's finger has moved across the screen and hence be able to determine what kind of swipe this is? For example, if the value of the swipe angle theta lies somewhere in this region, then we will consider this to be a right swipe. And if it's within this range, then it's an up swipe. Also, if the value of the swipe angle is in the dark pink region, then we'll consider it to be a left swipe. Finally, if it lies below the x-axis, then we'll consider it to be a down swipe. The question then becomes, how do we compute the value of the swipe angle in Unity? Well, that's easy. We first find the tangent of the swipe angle theta, which is opposite over adjacent, and then take the inverse tangent or the arctangent of both sides to get the angle. Now let me ask you a question to see if you had paid attention in your high school trig class. What is the value of the opposite side of the swipe angle theta? Well, it's just a change in height from the end position to the start position of the swipe, which is y2 minus y1, or delta y, or just dy. And what about the adjacent side? It's just a change in value along the x-axis, which is x2 minus x1, or delta x or dx. This means that the swipe value for the swipe can be computed by taking the arctan of dy over dx. And Unity has all the methods needed to make such computation, and it's really simple. Now let's go to the Unity editor and create a new script in the scripts folder, which we will call gestures. Let's attach this script to the player game object, and then open it up in Visual Studio. What we will do in this script is repeat the trigonometric calculations for the swipe angle in C#. So let's create 4 public bools that are going to store the state of each gesture swipe, and we'll appropriately name them swipe left, comma, swipe right, comma, swipe up, comma, and swipe down, and then initialize all of them to false. This might be the first time in this course that we have declared and initialized variables this way, but it's no different than declaring and initializing each of them in its own line. The only difference is that this is shorter, and we're making them public because we want to access their values from the player control script later in this tutorial. Now let's create a vector2 variable that we will call touch start pause, which we will use to store the xy coordinates of the swipe initial position on the screen before it's initialized to completion by the user. And then we'll create a float called min swipe pixels distance that we will use to determine whether we should go about detecting a swipe here in the script or not. Because remember, not every touch on the screen is a swipe, so we need to know that the user's finger has moved some distance along the screen. Let's make the minimum swipe distance 100 pixels, because if one of the user's fingers has moved 100 pixels across the screen, then for sure he intended that as a swipe. Let's go ahead and delete the code for the start function because we're not gonna need it in the script. Now what we want to do is constantly check whether the user has placed one of his fingers on the screen or not. And the best place to do that is of course inside the update function, because it's called once per frame. So let's write an if statement here that checks if a touch is detected on the phone screen by the user. If, parentheses, input.touchCount is greater than 0. Much of the touch methods in Unity are included under the input class. So this touch.count lets us know if the user has touched the screen or not. If that happens, then we want to create a local variable of type touch and name it t touch, and then set it equal to the latest registered touch on the phone screen by the user. So this input.touches bracket 0 gives us the latest touch by the user, and since we're running it inside the update function, we're guaranteed to get the latest touch from the user on the phone screen. Now this touch variable holds all sorts of useful information on the latest touch from the user. For example, we can know the phase of the touch from it, i.e. has it started, has it ended, or has it been cancelled by the user. So let's write a switch statement here that checks the phase of the touch, switch, open a pair of parentheses, touch.phase. If it's the case that the touch phase has begun, then we want to start the position of that touch on the phone screen in the touch start pause variable. So now we know the initial position of the touch on the phone screen. And let's make sure that we keep all the swipe bools as false because we don't want to detect a gesture swipe yet. Now Visual Studio treats this entire block as a single line because it has one semicolon. I've stacked this expression vertically after each equal sign because it looks neater this way. Code readability is very important. And let's have an empty line between these two lines. Now let's go to the second case of our switch statement, which is when the touch has ended. If the user has finished swiping one of his fingers across the screen, then we should go about detecting what kind of gestures he intended with that swipe. And we can know this by computing the swipe angle. So let's go here and create a new void function that's going to compute the swipe angle. Let's call it swipe. And it's going to take a touch variable as input parameter. So let's call this function here when the user is done with his swipe and pass our local touch variable from the update function as its input. The first thing we'll do in this function is create a local vector2 that we will call touch last pause and set it equal to the user's last touch position on the screen. Remember, we are calling this function when the user lifts his finger off the phone screen, so this position in the touch.position is by definition the last position in this case. Let's now create a float that we will call distance. This float is going to determine the distance between the user's last touch position and initial touch position on the screen. So let's use the vector2.distance method to calculate the distance between touch last pause and touch start pause. We'll then use it to check if the user intended that as a swipe by comparing it to the minimum swipe distance we've specified above inside an if statement. If it's greater than the minimum swipe distance, then it means that the user has made a specific swipe. So let's figure out what kind of gesture swipe the user wants inside the if statement. First, we need to calculate the change in height from the last position of the swipe to the start position of the swipe in a float that we will call dy. And we can do that by simply subtracting the final y position of the swipe from the initial y position of the swipe. Likewise, we need to know the change in the horizontal x direction between the final and start position of the swipe. So let's create a float named dx and then subtract the final x position of the swipe from the initial x position. Now we're ready to compute the swipe angle using these two floats. So let's create yet a third float here and call it swipe angle. And we'll use the mathf.atan2 method to compute the arctangent between dy and dx, which will give us the swipe angle as the result. So the first argument of this method is the opposite side to the angle, which is dy. And the second argument, separated by a comma, is the adjacent side of the angle, which is dx. Are we done yet? No, because this atan2 method of the mathf class outputs the result in radians, and we want them in degrees. So let's multiply this expression by mathf.rad to degree, and now we have the swipe angle in degrees. Unfortunately, Unity considers angles below the x-axis to be negative. To fix this problem, we'll add a full 360-degree rotation to the angle value itself, and then get the remainder of that value if we divide it by 360. You might be wondering, what the heck did I just do? I simply added 360 degrees to the computed swipe angle to ensure that it remains positive, and then I divided it by 360 degrees and got the remainder to ensure that it ranges from 0 to 360 only, which is what this percent sign means. Get the remainder of the division between these two values, and we're getting the remainder of this entire quantity with 360, so that's why I put this expression in parentheses, because we want Visual Studio to think of them as one quantity. Now we'll write an if statement that checks if the value of the swipe angle lies within different ranges that we will be specifying ourselves. If the swipe angle is less than 50 degrees, then this means that this must be a right swipe. So set the value of the swipe right bool to true. Else if the swipe angle is not 50 degrees, yet it's still less than 150 degrees, then this means that the user has swiped up. So set the swipe up bool to true. Else if the swipe angle is bigger than 150 degrees, but it's less than 190 degrees, then this will be a left swipe. So set the swipe left bool to true. Finally, if the swipe angle is bigger than 190 degrees, then this has to be a down swipe. So let's set the swipe down bool to true here. You know what? I'm worried that if the user intends to swipe right, then Unity will compute that angle as being close to 360 degrees and not between 0 and 50. So let's go to the if statement that checks if the swipe angle is less than 50 degrees and add another condition. So if the swipe angle is less than 50, or this is what these double bars mean in C#, or is greater than 355 degrees, then consider this to be a right swipe. So if the swipe angle is very close to the positive x-axis, then consider the swipe to be a right swipe. I hope that everything we're doing is making sense to you. I know it requires some thinking. Now let's go up here in the script and create a bool that's gonna let us know if a touch has started in the game by the user. Let's name it touch started and initialize it to false. The benefit of this bool is that it's gonna allow us to control when to call our swipe function in the script. So let's go to the switch statement that checks for the touch phases and set this bool to true first thing if a touch has started by the user. Then we'll go to the case when a touch has ended and write an if statement that checks if the touch started bool is true or not. If it's true, and remember it's only true if Unity registers a touch from the user. If it's true, then call the swipe function and then immediately set the touch started bool back to false because now the user has lifted his finger off the phone screen. Let's consider the case when the user cancels his touch gesture, i.e. he doesn't complete it. If that's the case, then simply set the touch started bool to false. Now our gesture detection code is technically complete. We are able to detect a swipe from the user's fingers on the screen in 4 directions. But let me take the time and introduce you to a really powerful feature in Unity and a crucial concept in game development called debugging, which is when you methodically look for errors in your code in order to understand it better, or more often, fix it. So let's go to the swipe function, write the following line of code after each time we set one of the swipe bools to true. So after we set the swipe right bool to true, start a new line and type debug.log, open a pair of parentheses, a pair of quotation marks. And between the quotation marks we'll output the string right to the Unity console window in the editor, so that we know that Unity has executed this line of code right after we swiped right on the phone screen, which will let us know that our code is working as intended. Let's copy this line and paste it here when we detect an up swipe, and we'll display the string up. And we'll do a similar thing for the left swipe. Let's display the string left. And finally, for the down swipe, we'll display down. You'll see how this way of testing our code is much more efficient, and it's really criminal that you take a course in Unity and not be exposed to it. So that's why I'm insisting on showing it to you, even though I know our code will work just fine. Let's do one final thing in this script. I do want to see these public bools in the inspector window of the player game object, so I'm gonna hide them. And the way to do that is by simply typing hide inspector between brackets before their declaration in the script. You see, you're relearning what seems to be everything about Unity in this course. Save the changes to our script and go back to the editor. Now how do we test swiping across a smartphone screen from the editor, which is running on a PC? Well, we're gonna have to create a new workflow to test the swiping behavior that we have just programmed in our game. You'll need the following items: a smartphone or a tablet running either iOS or Android, the Unity 5 remote app, which you can download from either the Google Play Store or the App Store, and finally, a USB cable that can connect your device to your PC. This Unity remote app will mirror the game window of the editor while it's in play mode to your smartphone screen. So let's see how we can use it. From Edit on the menu bar, select Project Settings. Then select Editor from the left. Under Unity Remote Settings, click on Device. If you're running the Unity Remote 5 app on an Android device, then select the Any Android Device option here. And if you're using iOS to run the Unity Remote app, then select Any iOS device. Now close the project settings window. Our editor is now ready to mirror our game to mobile phones so that we can test the gesture swipes functionality in our game. Connect your device via a reliable USB cable to your computer that's running the Unity editor. If you're using iOS like me, then it might ask you to trust your device. If so, then just hit trust. If you're using Android, however, then you must enable USB debugging, which is not enabled by default. So go to the web and type your device's name and then how to enable USB debugging, because it can be different on different phones. Then once you connect your Android phone to your computer, choose the Transfer Files USB mode. Okay, now once you've connected your phone via USB and then made sure that it's trusted, go to the Unity Remote app. Now hit play from the Unity editor. And as you can see from my other screen, Unity is pushing the game to my iPad 3. Yes, my device is that old, but it gets the job done. Don't worry that it looks laggy and unscaled. When we build it, it's gonna look just fine. Now I must warn you that the Unity Remote app is a crappy piece of software, believe me. It works on some machines but not others for some reason. If it's not working with you, then close the Unity editor and then run it again. Or try unplugging and reconnecting the USB cable. Okay, now let's select the player game object from the hierarchy and turn off its animator component as well as its player controller script. We're doing this because we're only testing the gesture swipes functionality and not the entire game. And as you can see, our public pools from our gesture script are nowhere to be seen here in the inspector window because we hid them. Let's turn off the bridge spawner script from the bridge manager game object. Let's turn off maximize on play. Now click on the console window here to see the debug messages we've put in our gesture script. If you don't have this console window for some reason, then go to window from the menu bar and then under general select console. You can then pin it anywhere in your editor. And here is the second screen showing you the game on my iPad so that you can see what happens in the editor when I make a swipe on the iPad screen. Save the changes and hit play. Nothing is happening, which is what we want. If I swipe right on my iPad, then the Unity console outputs the string right, which means that it's detecting right swipes on the phone or tablet successfully. And if I swipe up like so on my iPad, then the console outputs the string up, which lets me know that Unity has executed that part of my code. And if I swipe left, the console outputs left, so the left swipe is working properly. And finally, if I swipe down on my iPad, the Unity console outputs the string down, which indicates to me that Unity is reading that part of my code. Okay, let's exit play mode. You can see that this is a very handy way of testing our code. Now we know for certain that our gesture script is working exactly as we want it to. And we've tested it in a very simple but effective way. Being able to debug your game is just as integral to the development process as writing code, so you really need to master it. Okay, let's re-enable everything we've turned off, like the animator component of our player game object, as well as the player control script. Let's not forget to re-enable the bridge spawner script from the bridge manager game object, and then go to our project window. Now let's add the gesture swipe controls to our player's behavior. So let's go to the player control script in Visual Studio. Let's grab a reference to the gesture script component, which is also attached to the player game object, just like the player control script. So create a variable of type gestures here and name it small g gestures. And then go to the start function and set it to an instance of the gesture script component. We've done this so many times, you've probably beaten me to it. Now we can access all the swipe pools from the gesture script because we have made them public. Object-oriented programming, baby. We're now ready to condition the player's left and right turns in the game to when the user swipes left and right on his phone. So let's go to the player logic function and add a new OR condition to the if statement that checks if the user has pressed the G key on his keyboard and whether the player is running on the right corner segment. So the player can turn right in the game if these two conditions are both true at the same time, or the swipe pool from the gesture script is true and the player must be running on the right corner segment. So now let's read this if statement one more time. If the user has pressed the G key on his keyboard and the player is running on the right corner segment, then the player may turn right in the game. Or if the user swipes right on his phone and the player is running on the right corner segment, then the player is allowed to turn right in the game. Let's now do a similar thing for the left turn behavior, only this time it will be the swipe left pool that we're checking and the player must be running on a left corner segment. Now we need to make sure that once the player has turned either left or right in the game, the swipe right and swipe left pools must be turned off. So let's go to the onControl collider head function that checks what kind of segments the player is running on in the game and set the swipe right pool from the gesture script to false if the player is not running on either a right corner or a left corner segment, which is what this else statement checks. The same goes for the swipe left pool. Now let's go to the player logic function and go to the if statement that checks if the user has pressed the space key in his keyboard and whether the player is grounded in the game or not. Let's make a check for an OR condition, which is if the swipe up pool is true and the player is grounded, then the player should jump in the game. And after the player is done with his jump action, we must set the swipe up pool to false last thing. Finally, we'll go to the if statement that checks if the user has pressed the down arrow key in his keyboard and OR it with the swipe down pool. And let's not forget to set the swipe down pool back to false if the player is done with his sliding action. So let's go to the do sliding function and set the swipe down pool from the gesture script to false last thing. Save the changes and go back to the editor. Make sure that you've got your phone connected via USB to your computer and have the Unity Remote app open. Hit play, and I've included the second screen to show you what's happening on the iPad when I swipe one of my fingers. Swipe up to jump, swipe down to slide, swipe left to turn, jump, and if I click the respawn button on my iPad, then the player respawns. So let's test the right turn, swipe right, works great. Our game can now detect 4 swipe gestures from the user's fingers. You can also see that when I clicked the respawn button, Unity automatically detected it without us having to write any piece of code for it, which is nice. Also, I know that the swipe detection might look a little bit delayed on my iPad from when I first swipe my finger, but that's because there is an actual delay in the Unity remote. But as I said, when our game runs natively on mobile phones, it's gonna be perfect. Now I think that we may have to increase the detection range for the swipe right gesture from the gesture script to maybe 350 degrees. Now comes the end of this tutorial. This was perhaps one of my favorite tutorials to make because it combined everything that I like about game development: abstract logical thinking, problem solving, trigonometry, debugging, and much more. In the next tutorial, we'll integrate the data from the user's phone's accelerometer with Unity, so that the user can control the horizontal movement of the player in the game if he tilts his phone, just like in the real game. Thank you.